Alright, let's learn about eddy currents. In this section we will see what eddy currents are, how are they produced, and what is the direction of the eddy currents, what do they do. Right, so what is the difference between eddy currents and the induced currents? If we see induced currents are generally generated or produced in the closed loops only. Whether that can be like induced current is produced because of the changing magnetic flux, or like DC AC currents are also generated or produced in the loops of wires where the loops are closed. Now in this case, what we see here, if this loop is moving to the right, the magnetic flux is decreasing, so automatically the induced current will try to oppose the decrease in the magnetic field and it will try to produce the magnetic field into the page. So we know that there should be some magnetic field. There should be some magnetic field produced into the page because the external magnetic field, which is in red color, is decreasing because the loop is moving to the right. That decreasing magnetic field or that decrement in the magnetic field should be opposed by the induced current. So it should produce the magnetic field in the same direction. So in order for the magnetic field to be produced into the page by the induced current, that induced current now should have developed in the clockwise direction, which passes along the loop, inside the loop itself or across the wire. But if we look at the eddy currents, now eddy currents are completely different from the induced currents, where they do not require any conducting path like a loop of wire, or where it need not be any wire, because the induced currents are limited only in the loop areas, loops of the coils, right? But if we look at this one here, the eddy currents are produced in the plane sheets which are moving in the magnetic field. So where there is a relative motion between the magnetic field and the conducting sheets, then there will be some eddy current that is developed in the conducting sheet. So what will be that eddy current direction? Will it go on the edges of this sheet, or will it go in this region where the person is holding that sheet? Where, or how is that eddy current going to complete a loop, or where does it going to be generated? Let us see that. So whatever may be the case here, whether it is a loop or a plane sheet, conducting sheet, either case, according to Lenz's law, the current should oppose that change, whether it is induced current or eddy current. It should oppose that change, whichever is producing that induced current or eddy current. Fine. So now in order to see this, if we take certain area here, insert a certain section of area here, let us say this is the section of area. In this section, the magnetic field is going to decrease, because as in the next moment, as this is being moved, as this sheet is being moved to the right with velocity v meters per second to the right, in this region, all this region will be losing that magnetic field. Because it is going to lose that magnetic field, in that region there should be some magnetic field, but that magnetic field should be pointing into the page. So if we say that if I want the magnetic field should be going into the page, because the external magnetic field is decreasing, now the eddy current will produce its magnetic field so that it will add on to it, so that it will not let the decrease to happen. So in order for the magnetic field here to be in this direction, okay, so I want the current to be looping in upward direction. So there will be a loop of current that is going upwards, and then outside that region it will just come downwards and join the loop. So it will complete the loop by going like this, right? That means the region where the magnetic field is decreasing, in that region it is trying to produce its own magnetic field that is passing into the page. So for that to happen, in that region the induced current should go in upward direction. So it might be this big loop or very small loop like this. We can have a very small loop of current also, but the condition is the current in the section on the left side of this dotted line should be going upwards. So anywhere on the sheet you must see there must be some current going in upward direction, and which is completing the loop in the region where there is no magnetic field at all on the outside part, and it will complete the loop by joining. So we will see one more example to understand it more clearly. So if we look at this one, there is a conducting disc that is rotating in an anti-clockwise direction. Okay, and there is a small region here in the circular region which is given, which has some magnetic field going into the disc perpendicularly onto the surface area of the disc, which is very small region. The rest of the region there is no magnetic field. But as the disc is rotating, because that disc is rotating, different regions of the disc or different sections of the disc are entering into this magnetic region, magnetic field region, and leaving that magnetic field region, right? So that means a region like C here, a region like C, let us say this section here, this is the region, and this region initially now it doesn't have any magnetic field there, but this region is now going to enter into the magnetic field because of the rotation. So the moment when it is going to enter into the magnetic field, what is happening in the region's magnetic field? In that region the magnetic field is going to increase into the page. That means there is going to be a new magnetic field that is going to be there, and that is pointing into the magnetic field. So now the induced current will be generated such a way that, because in this region I have the magnetic field that is going into the page, I need some current, that means in this region I need some current, okay, that will generate the magnetic field coming out of the page. So this magnetic field that is coming out of the page, which is generated here, will oppose the change that is happening in that region. So in order for this loop to complete, this loop should get into the magnetic field region, and in the magnetic field region, if you look at that, the current is going in upward direction. So as the section is coming into the magnetic field, there you have the magnetic field coming out of the page. So this will complete the loop. Now if we see on the other side here, section D and E. Now the section D is already in the magnetic field, but when it reaches to the position E here, it will lose its magnetic field, right? This is going to lose its magnetic field that is going into the page. So that means because it is going to lose its magnetic field, I need something or a current that will produce the magnetic field into the page here, so that even though the external magnetic field decreases, this magnetic field will be there. So in order to complete the loop for this current here, now it should go out of the region of the magnetic field and come back and join here. So I will have a magnetic field going downwards here in the outside the magnetic field region. In the magnetic field region, I'll have the magnetic field, current going in upward direction. Now how can we justify that? Okay, according to Lenz's law, we have given that some explanation, but also it should, the force that is keeping this disc to rotate in a anti-clockwise direction, that force should be opposed by some other, because this force which is keeping this disc to rotate in a continuous with a constant angular velocity is doing some work on the disc. So this work that is being done on the disc should should be seen in some way or the other, right? So that whatever the eddy current is generated here, if we look at that eddy currents and that sections, what will happen to them? Let me just remove that. I will make a clear picture here. Look at this. So we have anti-clockwise section of current loops and clockwise section of current loops in different places, as we have already seen in the previous diagram. Now if we look at this section of the eddy current here, that means though it is not a wire, it is just flowing in the sheet area. Now that particular region where there is a current that is going in upward direction, that is also there in the external magnetic field. That means it is nothing but I have some current going in upward direction in that region, okay, and this one is in the magnetic field that is going into the page. So if I take that magnetic field going into the page and the section of the current that is going upward in the disk there, this section of that disk will experience a force, magnetic force in that direction, in towards the left. That means this force is going to oppose the rotation of the disk, right? So the faster the rotation is, the higher this force going to be, the higher the eddy currents going to be. Now on this section we have seen. Now even if we look at the other section also, this section also, they are also going in the upward direction. The section here near the D, they are going in upward direction, the currents are going in upward direction. So, and this section of the plate also, or the disk also, will experience force in the towards left side. So anywhere you see within the magnetic field area, all that sheet is going to experience a force towards left, right? So which will oppose the motion. That means gradually the magnetic force which is applied on that is going to convert the mechanical energy into thermal energy, which develops in the sheet, right? Okay. So these currents which are generated in the sheet area, within the sheet area, between that regions where there is magnetic field and where there is no magnetic field, and where there is a change in the magnetic field, right? Only in that region the eddy currents are going to be generated, and the eddy currents are not confined to some specific loop, because there is no loop here, but the current by itself will form a loop, closed loop, in the plane surface area of the disk or the sheet that is moving in the magnetic field. That means these eddy currents are going to take place in the surface area of the sheets, not across the edges of the sheet, or not they won't be in the there is no conducting wire, but in the conducting plate or conducting sheet surface area itself they will form the loops. And because these eddy currents are being formed here, those eddy currents, in the sense like that area of the section of that sheet is going to experience some opposing magnetic force, which will convert that mechanical energy into thermal energy in this case. Let us see one more example. Now as this conducting sheet here pivoted to one edge, and there is some magnetic field in this dotted line which is pointing into the page. So as the sheet tries to oscillate to and fro in the magnetic field here, as the sheet is entering into the magnetic field, if I take the section A here, in this section there is no magnetic field initially, but in that section there is going to be some magnetic field which is going into the page. Once the section enters, it is gaining some magnetic field that is entering into the page and increasing. So now the induced current will generate in such a way, it will produce a magnetic field that is going to come out of the page. So I want the magnetic field here to come out of the page, right? So that the magnetic field which is coming out of the page will oppose the magnetic field that is going into the page when this sheet enters into the magnetic field. So if I want the magnetic field to be coming out of the page here, I need some current in this direction, in the downward direction like this, so that here I will have the magnetic field of that coming out of the page. So for this current to complete the loop, okay, as it enters the magnetic field region, I took a small section A here which is about to enter into the magnetic field. So because this is going to this section is going to enter into the magnetic field of external magnetic field. Here I am expecting some magnetic field that comes out of the page. So if we can expect that there should be some magnetic field that is coming out of the page in this section which is about to enter into the magnetic field of the external magnetic field as it oscillates downward. So for this to happen, I need some current in this section to be developed that is going in the downward direction. So now for this, if this current has to be there, I need this current to complete a loop and make it as a loop. So the current should be something like this, right? So that everywhere here I will have that magnetic field that is coming out of the page which will oppose this, which will oppose the increase in the magnetic field, right? Now if we look at this different sections where the eddy current has been produced, if we look at that, we will see one section of it. So in the section here, this section of the eddy current which is produced, that means when this section enters into the magnetic field, that loop current is there, that eddy current is there. That means that section of the sheet or that particular current loop will be in such direction like this, something like this. So let us assume that that is the direction of the current going this way, right? And there is magnetic field going into the page. This is the external magnetic field and the loop is going to enter. As the sheet is entering, this eddy current has come in. Now because this is a current, which is passing in the plate, no matter whether it is passing in the conducting wire or in a plate, there is a loop of current here. So this loop of current will experience a force perpendicular to this current. So if I consider that this one is something like that, there will be an opposing force on that particular loop. So because of this opposing force, that means in this section if I show here, there will be some opposing force in this direction on that as this enters. As this sheet is entering into the magnetic field, I have the eddy current, and because that eddy current has been produced, that eddy current loop is experiencing a force upwards. So the force which is trying to pull it down is the gravitational force, let us say, and this wants to keep the thing to oscillate, right? But because of this motion, there is an eddy current that is developed, and because of that eddy current there is an opposing force on that. That means automatically the sheet will come to rest or gradually decreases its oscillations amplitude, and finally it will come to rest. But even though if this eddy currents are not there also, it will come to rest, right, because of the friction and all. But what is the difference between this and that? Means here it will come to rest a little quicker than just coming to rest under the gravity or air resistance. So this is an additional opposing force other than the friction and the air resistance or any other force which is opposing. So in order to overcome, or in order to oppose the force that is pulling it downwards, there is a force that is developing in the opposite direction, right? So the eddy current that is produced is going to experience some force, and the mechanical energy that this has, which is converting now into eddy currents, and that eddy currents are going to generate some heat. That means by the time the sheet comes to rest after making some oscillations, all this time whatever the mechanical energy is being lost by the oscillating system will convert into heat because of the eddy currents that are developed in the sheet. So now there are many applications on this eddy currents. We can see them one by one. Coming back to this previous picture, we can see this one is the disk, and we understood that this disk is going to experience, or these eddy currents are going to experience some force which opposes the rotation, right? So now the same disks can be used in the braking system, where this disk will experience the magnetic force, right? So by allowing high currents or electromagnets to be generated there or produced there, by producing some electromagnetism while the disk is running, due to that electromagnetism or the magnetism that is developed, the disk will develop some eddy currents, and that eddy currents will experience some opposing force which will instantaneously bring that disk to rest. So these can be used in the transport section, where the bikes or the cars can be in the braking system of these vehicles can be used. I hope you understood the eddy currents and their production, and how are they helpful in different applications. Thank you for watching the video. If you have liked the video, please share it and subscribe, and click the bell icon so that you can receive notifications when new videos are uploaded. Thank you.